1. 4, 3, 2, 1. Good afternoon, fellow engineering students. This is Chris Lafayette once again, coming to you from an undisclosed location at Colorado State University. And today our goal is to investigate lab number 11. Lab number 11 involves a sequence generator where we're going to try to detect two sequences, particularly 0, 1, 1, and 0, 0, 1, 0. Now, these are two binary digits in the form of 2 and in the form of a 3, not respectively there. Okay, so let's get started. A little background. The last two switches 9 and 8, are controlling our sequence generator today. That will control input, parallel input, left, right, and freeze. So right now we're in the off position for those two guys, and we're allowed to input some information. Also, we're going to be making use of the push buttons on the right here, S0 and S1. S0 is going to be our clock. S2 is going to be our reset button. So right now we're sitting at 0, 0. Nothing is happening. So let's enter our first attempt to detect the sequence of 0, 1, 1. To do that, we're going to enter that over our input switches. And so here we're going to go 0. We're going to put this into 0, 1, and then 1. 0, 1, 1. That's a 3. Now, the display is really only for convenience so that we can see a little bit what's going on. So we're going to hit our clock a couple of times. And again, this is a push button clock, not a real clock. So it takes one or two clocks to get something to happen. So first clock, second clock. There's our 3. Now you'll notice that the last LED 9 lights up. Now that's a good thing because that's indeed what we want to happen. We want to detect a 0, 1, 1, which is a 3, and that last LED is going to come on whenever it detects a 0, 1, 1 or a 3. Now we can move in any direction here. We can move left or right by striking the clock. In this case, we're going left. And also, I just wanted to make note that these minus signs on the last two digits of the display indicate an inverse operation, depending on whether the 0010 is active, which I believe is the far left, and or a 011, which I believe is the right minus sign there. So keep an eye on that. That's just for convenience. It lets us know that in addition to be something being detected, we're also reversing it or inversing the signal. So right now we're just traveling through to the right, and you can see when it detects a 3, our far left LED comes on and the minus sign comes on to let us know that the signal is being inverted when it detects the 3. Now, if we want to try to go back to a normal signal and detect a 2, which is a 0010, let's do that. So we activate the input to the parallel in, serial out, and and let's enter 0, 0, 1, 0 and try to detect that. In that case, the LED 8 is going to light up whenever it detects a 2 signal. And in addition to that, it will invert this signal by changing this minus sign over to the far left. So there's a 1, there's a 2, there's a 2, and there indeed there's our indication that it has detected the 0010 signal by activating the LED 8. And one more clock should activate the reverse. There we go. It activated the reverse, and now we're back to our normal signal. So let's see if, and again, we could move this around, move this signal back and forth manually. To indicate, to check to see what's happening. There's a 002, and again, it's the same condition. We illuminate the LED 8 and inverse it, and reverse it, I should say, indicated by the minus sign. So as long as we have that 02 in there, we're going to stay in that condition. Okay, now let's reset everything, and let's see what happens if we load all ones. Well, let's start off with zeros. Let's load all zeros and then see what happens. See if anything gets detected with all zeros in there. And we'll go to activate our parallel input, and we'll execute the clock signal and see what happens. Okay, random information is in there. Nothing oh well, first we gotta move that into, yes, okay, so again, we'll try that with 0. Theoretically, there's 0 bits in there, but we are operating a clock manually here, so some noise is liable to get in there and cause a bit to occur. Yeah, that's going to be normal for this situation as we put our clock in there. So notice how we put some random bits in there. There's actually supposed to be 0 bits in there, but it did detect that 2 again. It detected a 2 just because of a random bit situation. So we'll hit that back to 0. Now if we move this through, we'll see that nothing's going to happen because there's really 0 bits to work with in there. Okay, so it's stuck on 2, but there's nothing occurring because there's 0 bits in there. And the display, the 2, is a random recording because that's operating on a different clock than I'm operating here. So any random noise in there is going to set that display and keep it there until we actually move some bits through the sequence detector. So let's try for all ones here. Let's put all ones in. First we'll bring back to 0. Let's put in all ones and see what happens there. Nothing should get detected with all ones in there. So all ones are loaded in. Let's load them in like so, all ones. And you can see all the LEDs light up. No LED for 9 or 8 comes on. Okay, so because there's all ones in there for a signal, and in that case, the sequence detector will not detect anything, even as we push the clock. Even as we rotate the clock through there, nothing is going to happen. Nothing's going to happen with all ones in there. Now, if we just put a large set of ones in there, like so, move them through, clock them in, and move them in. As you can see, only under certain conditions will it detect a 0010, which is pretty much how it should work. All right. Once again, we'll go back to we'll reset. We'll enter 011. Okay, 011 clock, and we do get a detection on 011. Hit the clock again to push it through. And there we go, 002 activates. There's 003, and as you can see, with a 3 in there, which is a 011, LED 9 comes on, and it gets inverted as indicated by the minus sign there. Okay, all right. Let's go the other direction just to see how it behaves. Again, we're clocking through, so the bits change as they should, and only when the sequence detector detects the 011 or the 3 will the LED on the far end, which is LED 9, light up. And continuing with the clock, we should invert it, indicated by the minus sign. So hopefully that demonstrates what we're trying to do here. Again, when you see it, when you push these binary bits through there, you're going to get like various bits, and sooner or later they're going to indicate either a 0010 or a 011. And from that, we can really see this is working just exactly how we would like it to work. Okay, so that should do it, guys. Hope this demonstrates the operation of a sequence detector circuit for lab number 11. And I believe that's going to be a wrap. We'll pan around here a little bit just to indicate who we are. Okay, once again, this is Chris Lafayette coming to you from Colorado State University Engineering Department. And this is, again, lab number 11. And we are out.